Hello everyone, welcome to today's tutorial. Today I'm going to be introducing us to differential equations. What is an ODE? An ordinary differential equation is a type of differential equation that has one or more derivatives along with an unknown function y with respect to only one independent variable x. So we're going to be discussing about the order and degree of an ODE. What is an order of an ODE? The order of an ODE is simply the highest derivative present in what? The given ordinary differential equation. The highest derivative present in the given ordinary differential equation is the order of that ordinary differential equation. Now looking at the given examples here, we observe that the ODE has two derivatives. The first derivative has a 5 and the second derivative has a 3. The derivative with the 5 is the derivative with the highest order. Therefore, this ODE is an ODE of order 5. Right, so coming to degree of an ODE, the degree of a given ODE is simply the power of the highest derivative present in that given ODE. Alright, so looking at the given example here, we observe here that the highest derivative here is what? Is the second derivative, and the derivative here is raised to the power of 3. This simply implies that what? 3 is what? The degree of the given ODE here. To classifications of ODEs. Ordinary differential equations are classified into linear ODEs and nonlinear ODEs. Nth order linear ODE. Now the general form of ODE, yn is equal to f of x comma y prime comma y prime prime comma dot 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 comma yn minus 1. It's said to be an nth order linear ODE if it can be written as a linear combination of its derivatives in the form a0 of x yn plus a1 of x yn minus 1 plus an of x y is equal to rx. So here our x here is an independent variable, our y is an unknown function, our n here is the highest order of the ordinary differential equation, our yn is the derivative with the highest order, or y prime up to yn minus 1 are the derivatives with the lower order, or let me say the lower order derivatives. R of x, of course, is an arbitrary function. Like I said earlier, it could be trigonometric, it could be exponential, it could be logarithmic. Example, sine x, ln x, exponential x, as the case may be. So our a0 of x to an of x are called real and constant coefficients. These are called real and constant coefficients because they are coefficients that are known already. The values of the coefficients, the value of the constants are known. They could be 1, they could be 2, could be 3, and the case may be. Unlike some other coefficients that the values are unknown and may have to be calculated. Talking about homogeneous and non-homogeneous linear ordinary differential equation. A linear ordinary differential equation is said to be a homogeneous linear ordinary differential equation if the right hand side of our equation here is equals to 0. What I mean is if our r of x is equals to 0, that means if the given ordinary differential equation has no arbitrary function at the right hand side of it, then such ordinary differential equation is said to be a homogeneous linear ordinary differential equation. However, if our r of x is not equal to 0, what I mean is if the ODE given has a right hand side, probably a sine x, an exponential x, or even an x itself, then such ordinary differential equation is no longer a homogeneous ordinary differential equation, but is known as a non-homogeneous linear ordinary differential equation. So to check if an ODE is a linear ODE, we must take notes of the following tips. First, there must be no derivative having a non-constant coefficient. That means all the derivatives must have a constant coefficient. Secondly, none of the derivatives must have more than 1 degree. Thirdly, the unknown function y must not have more than 1 degree. And the last thing is there must be no product of the unknown function and any derivative at all in the given ODE. If all of these four tips are observed, then we can say the ODE is a linear ODE. If otherwise, then it is a nonlinear ODE. Alright, so here are some examples of nonlinear ODEs. I'm going to be explaining to you why they are nonlinear ODEs using the tips I just gave earlier. So the first example we have here is the square q, the t square is equals to what? T all over q. Now if you check the right hand side of this ODE, you see that there's a fraction t all over q there. If you decide to cross multiply, because at first it may look normal, but if you decide to cross multiply, you will see that the left hand side, which is the derivative, will have a what? A coefficient, which is what? Q. So you are going to have q, the square q, the t square is equals to t. Now the q there is an unknown function, and from one of our tips here, there must be no product of what? The unknown function and the derivative. So the q here being the coefficient of the derivative and also being what? The unknown function has disqualified this ODE from being a linear ODE, and that is why this ODE is a nonlinear ODE. The second example here we have mu the square y the x square plus 2x is equal to 0. Why is this ODE a nonlinear ODE? This is because if you take a look at the coefficient of what? Our derivative at the left hand side, you will see that mu is not a constant coefficient but a what? It is a non-constant coefficient. The value of mu is not known. Therefore, this disqualifies this ODE from being a linear ODE and rather a nonlinear ODE. The last and not the least, we have the square y the x square or cube plus what? The y the x or to the power of 6 equals to what? 0. Now, one of the rules here will say that what? The derivative must not have the more than 1 degree. But if you observe the two derivatives here, both the second, the highest derivative and the lower derivative, that is both the square y and the dx and the dy dx, they have degrees that are more than 1. The first one has a degree 3 and the second one has a degree 6. So because these two derivatives do not have 1 degree, they have more than 1 degree, this disqualifies this very equation from being a linear ordinary differential equation, rather making it a non-linear ordinary differential equation. So you could try out some examples on your own, and if you have any confusion, you can just table your question in the comment section. Thanks guys for watching.